हेलो एवरीवन, कैसे हैं आप लोग। आज हम लोग डिस्कस करेंगे कुछ और टाइप्स ऑफ कंस्ट्रेंट्स जो कि हमारे जिससे कि क्वेश्चंस बनते हैं हमारे मेंस में और एडवांस प्रॉब्लम्स जो बनती हैं, ताकि हम पूरी तरह से अपना कंस्ट्रेंट का चैप्टर ख़त्म कर सकें। सो दिस इज़ द फाइनल पार्ट ऑफ कंस्ट्रेंट्स। अच्छा, फाइनल पार्ट मतलब फाइनल थियरी पार्ट। ऐसा नहीं कि मैं इसमें क्वेश्चंस नहीं दूंगा, मैं कंस्ट्रेंट में काफ़ी क्वेश्चंस दूंगा, उसको मैं अलग से सेपरेट वीडियोस में आप देख सकते हो, वो दिए हुए होंगे। लेकिन फिलहाल अभी हम सिर्फ थियरी पार्ट में करते हैं अपने आप को फोकस, और हम ये देखते हैं कि सेकेंड टाइप ऑफ कंस्ट्रेंट्स क्या है। दीज आर कॉल्ड एज कंस्ट्रेंट्स ऑफ वेजेस। What are constraints of wedges? So let's first discuss the driving idea behind it. What is the driving idea? What is the main idea? What is the main idea? Let's consider one wedge and let's consider another wedge. So these are our two wedges. Correct? Now the question is it possible that this wedge moves forward with 3 meter per second and this wedge moves backward with 2 meter per second? तो आपने अगर किसी भी सरफेस पे किसी ऑब्जेक्ट को स्लाइड कराया हो, जैसे कैरम पे डिस्क्स, उनकी जो गोलियां होती हैं वो स्लाइड करती हैं, आप अगर एक टेबल पे किताब रखो तो वो उस पर स्लाइड कर सकती है। तो आपने अगर किसी सरफेस पे किसी ऑब्जेक्ट को स्लाइड कराया हो तो आपको ये पता होगा कि हाँ, ये पॉसिबल है, इट इज पॉसिबल, एंड इन दिस प्रोसेस द कॉन्टैक्ट विल नॉट ब्रेक। द कॉन्टैक्ट will not break between, let's say, A and B. So the contact will not break between A and B. ठीक है, अब मैं क्या डिस्कस कर रहा हूं, मैं चाह रहा हूं कि आप बहुत ध्यान से मेरे साथ रहें, बिकॉज जो चीज मैं डिस्कस कर रहा हूं बहुत इंपॉर्टेंट है। दैट इज द ड्राइविंग आइडिया बिहाइंड द कंस्ट्रेंट्स। यहाँ पे मैं दो डायरेक्शंस बना देता हूँ, ब्लू लाइन से आप देखो, there will be two directions here. If you look at this line, this is parallel to the surface. To the surface. If you look at this line, this is perpendicular to the surface. And what I am saying is that we can have different velocities and accelerations. We can have different velocities and accelerations parallel to the surface, but the contact will not break. That is what I am saying. मैं जो कह रहा हूँ वो बहुत ही important है. All I am saying is that we can have velocities and accelerations parallel to the surface and the contact will not break. Now let's come to the second part of this main idea. Let's take this wedge here and let's take another wedge here. Let me draw two lines. This is parallel to the surface. And this is perpendicular to the surface. Now the question is that is this possible that this moves with 2 meter per second and this moves with 3 meter per second. Is this possible? It is possible. I'm not saying it's impossible. It is possible, but the contact will break. This block will start to move in a different direction and this block will start to move in a different direction, and the common surface, it breaks, the contact breaks. So the question is, what is जो सबसे इंपॉर्टेंट सवाल हम यहाँ पे पूछना चाह रहे हैं वो ये है कि व्हाट इज द क्राइटेरिया फॉर टू ऑब्जेक्ट्स to remain in contact. What is the criteria for two objects to remain in contact? Now I want you to pause this video and think on it कि what could be a possible criteria for two objects to remain in contact. चलिए, अब अगर आपने सोच लिया है तो let me answer this question. The objects should have same velocity and acceleration along this perpendicular direction. अगर इधर डिफरेंट हुआ तो काम नहीं होगा, द कॉन्टैक्ट विल ब्रेक. ये डिफरेंट हुआ चलेगा, ये डिफरेंट हुआ चलेगा. जैसे कि कोई ऑब्जेक्ट, जैसे आप मान लो कि आप किसी ऑब्जेक्ट को जमीन पे स्लाइड करा सकते हो, तो उस ऑब्जेक्ट का और जमीन का जो वेलोसिटी होता है वो डिफरेंट होता है, बट स्टिल द ऑब्जेक्ट रिमेन्स इन कॉन्टैक्ट. गॉट इट? लेकिन आप यहाँ पर कॉन्टैक्ट नहीं बना सकते क्योंकि यहाँ पे वेलोसिटीज डिफरेंट है. So the condition for the contact to remain, or the condition for contact to keep itself in that situation, contact के बने रहने की condition ये है कि the objects would have same velocity and acceleration perpendicular to the plane of contact. To the plane of contact. So I'll discuss more about this with some of I'll take up a few more examples in the next page. Okay. All right. So I have two examples here. ध्यान से देखो. Consider this object A and this object B. Do they have different velocities along the contact or parallel to the contact? क्या parallel to the contact इनकी velocities different है? Yes, different है. क्या इनमें contact छूटेगा? नहीं छूटेगा. क्यों नहीं छूटेगा? क्योंकि परपेंडिकुलर टू द कॉन्टैक्ट दोनों की वेलोसिटी जीरो है. In this direction both the velocities are equal to zero, and hence since the velocities are equal in that direction the contact will remain. This is 1 meter per second. This is 2 meter per second. This is moving in this direction with 3 meter per second. And this is also moving in this direction with 3 meter per second. Parallel to the contact, do they have same velocity or different velocities? Let me mark it also. The first case, parallel to contact, VA equals to 2 meter per second, VB equals to 3 meter per second. Perpendicular to contact, VA equals to 0, VB equals to 0, hence contact will remain. यहाँ पे parallel to the contact, let me again mark it as A, or let me mark it as P, let me mark it as Q. So parallel to the contact, VP equals to -1 meter per second. Let's किसी को तो माइनस लेना पड़ेगा. VQ is equals to 2 meter per second. Different velocities, but perpendicular to the contact, it is 3 meter per second. VP equals to VQ equals to downwards जा रहा है तो -3 ले लेते हैं. चलो -3 meter per second. Now I want you to understand this कि दोनों ही सिनेरियोज में परपेंडिकुलर टू द कॉन्टैक्ट, व्हाट इज द इंपॉर्टेंट पॉइंट, द परपेंडिकुलर टू द कॉन्टैक्ट दोनों की वेलोसिटी सेम है, हेंस द the contact will remain. The objects will remain in contact. बस इतना ही मैं आपको समझाने की कोशिश कर रहा हूँ कि पैरेलल टू द कॉन्टैक्ट इस डायरेक्शन में वेलोसिटी सेम हो डिफरेंट हो कोई फर्क नहीं पड़ता, लेकिन कॉन्टैक्ट बने रहने के लिए इस डायरेक्शन में वेलोसिटी सेम होनी चाहिए. दैट इज द कंडीशन ऑफ two objects maintaining contact. Okay, so the main thing that we had learned about, the contact, the condition to remain in contact is written here. I want you to read it again, and when you have read it, pause कर लो, देख लो, सुन लो, उसके बाद हम आगे चलें. पॉज कर लिया, देख लिया, अब यहाँ पे ध्यान से देखो. ये मानते हैं कि ये एक्सेलरेशन a1 से नीचे आ रहा है, ये मानते हैं कि ये एक्सेलरेशन a2 से आगे जा रहा है. And a simple thing that is being asked from you is find out the relationship between a1 and a2. अच्छा, there is one important thing कि why is this block सिर्फ नीचे आ रहा है, why is this block only coming down, why is this block not moving left or right? So this block is not moving left or right due to the two walls, the walls here, they are not allowing the block to move right or left, वो सिर्फ allow कर रहे हैं block को move करने के लिए up or down. ठीक है, और आपको निकालना है a1 and a2. Now how do we find a1 and a2? First we try to find out the contact, we try to understand where is the contact. So this is our contact and we will draw this contact separately. सारे steps देखते जाएंगे. First step is to draw the contact. Let me write down the step 1. Draw the contact. Also draw the perpendicular to the contact. When you have drawn the contact, also draw the perpendicular to the contact. Also draw the perpendicular to the contact. And then when you have drawn both of these lines, then comes step 2. Show the acceleration of the objects at the contact point. So the acceleration of first one is a1 downwards and the acceleration of the second one is a2 forwards. Third step, find the component along the accelerations. Find the component along the accelerations. Not along the acceleration. Find the component of the accelerations along the perpendicular. Component of the accelerations along the perpendicular. What is the perpendicular? The perpendicular is the blue line. So just find out the component of the accelerations along the blue line. So what is it going to be? If this is angle theta, if you can see here the red mark, this angle theta. So we can say this angle is theta. This angle will be 90 minus theta. This will be theta. So the component of A2 will be A2 cos theta, A2 sin theta. And the component of A1 will be A1 cos theta. And what is the rule? They will have same velocities and accelerations perpendicular to the plane of contact. So along the blue line, the value of accelerations will be same. That is step 4. Step 4 will be along the blue line, along the perpendicular, the accelerations will be same. So a2 sin theta equals to a1 cos theta. Or we can simply say that a1 equals to a2 tan theta. Again, I'm restating it. Along the perpendicular, let me draw this here. Along the perpendicular will be called as a wedge, and the yellow object will be wedge, and the blue object will be the block. The wedge and the block will have the same acceleration, same velocity along this white line, along the perpendicular, along this blue line. यहाँ पर देख सकते हो, along this blue line they will have same acceleration. So a2 sin theta equals to a1 cos theta. That is how it is done. So this is a very interesting problem. You have placed a block. This is a block here. You have placed a block on a wedge. All right. And you are now asking a very important thing. How will the wedge and the block move? As in, we want to picture out. हम इस बात को सोचना चाहते हैं कि wedge और block move कैसे करेगा. तो few things जो कि हमें दिख रही हैं, that the block will slide. Yes, of course, it will slide. But that's not just the only thing. The block will also push the wedge, so the wedge will move backwards, right? So let's look each of those things one by one. Let's copy this block so that we can. Right. So let's say that the block starts to slide downwards. Okay, and the block slides downwards. It's moving very strange ways, but chalo theek hai. The block slides downwards. Okay, and let me also change the color of this thing. Right, the block slides downwards. That's okay, that's fine. The block slides downwards. Okay, good. What about the wedge? The wedge goes back. Yes, the wedge goes back. Yes or no? The wedge moves back. But here is a problem. क्या आपको problem दिख रही? Can you see the problem? कि अगर सिर्फ ब्लॉक डाउनवर्ड स्लाइड करेगा और वेज बैकवर्ड्स मूव करेगा तो ब्लॉक और वेज के बीच में एक गैप क्रिएट हो जाएगा. देयर विल बी अ गैप ऑफ अ डिस्टेंस बिटवीन द ब्लॉक एंड द वेज, एंड द ब्लॉक विल इट विल लिटरली बी फ्लाइंग इन द एयर. मतलब ब्लॉक हवा में उड़ रहा होगा क्योंकि कांटेक्ट तो छूट गया. तो ब्लॉक नीचे मूव किया, एवरीवन विल से फाइन द ब्लॉक मूव्स डाउनवर्ड्स, इट विल स्लाइड, फाइन, ठीक है, ओके. वेज पीछे मूव किया, ठीक है, दैट इज ऑल्सो ओके. लेकिन अगर वेज पीछे मूव किया और ब्लॉक नीचे मूव किया तो इसका मतलब ये हुआ कि इनके बीच में जो कांटेक्ट है वो ब्रेक हो गया. तो इसका मतलब ये हुआ कि हमारा जो ब्लॉक है वो तो हवा, हमारा जो ब्लॉक है, दिस ब्लॉक हियर, ये तो हवा में उड़ रहा है. तो ऐसा नहीं हो रहा है. हो ये रहा है कि हमारा ब्लॉक जो है वो इस तरह से मूव कर रहा है. अब इस तरह से मूव करने का मतलब ये होता है कि ब्लॉक हैज गॉट two kinds of motion. One of the motion is along x-axis. Let me call this as Vx. And one of the motion is along perpendicular. Instead of calling it as Vx, let me call this as parallel, V parallel. And let me call this as V perpendicular. So it moves also along V parallel, or we can say that it moves parallel to the plane, and it also moves perpendicular to the plane. It moves both ways, right? And the wedge moves only in the backward direction, so we will call this as V naught. जब भी एक ब्लॉक और एक वेज दोनों मूव कर रहे हो फ्रीली, तो देयर आर There are two categories of motion in the block, that is, one of them is V perpendicular and other one of them is V parallel, and the wedge moves only backwards. Got it? Now there is a relationship between V perpendicular and V naught. How do we find out the relationship between V perpendicular and V naught? So we use the same constraint equations. If you do remember, let me draw the contact. Now let me draw the perpendicular. The wedge is moving with a speed that is V naught. The block is moving with two speeds, that is V perpendicular and V parallel. अब यहाँ पे आपको ये समझना होगा कि पैरेलल वेलोसिटी का कंस्ट्रेंट से कोई लेना देना नहीं होता है. हमने ये बात पहले भी डिस्कस करी है कि पैरेलली ऑब्जेक्ट्स, जैसे आप एक सिंपल सा केस समझ लो कि आप एक सरफेस ले लो और आप इसके ऊपर एक ब्लॉक बना लो. ठीक है, तो ये ब्लॉक सरफेस पे पैरेलली डिफरेंट वेलोसिटीज से मूव कर सकता है, उससे कोई फर्क नहीं पड़ता है. फर्क सिर्फ इस बात से पड़ता है कि परपेंडिकुलर वेलोसिटीज दोनों की सेम होनी चाहिए, अदरवाइज फिर कांटेक्ट छूट जाएगा. If the perpendicular velocities are not same, then the contact will break, and that is the only criteria here. So this is what happens. V naught, let me call this as angle theta or something. So this will also be theta. So V naught sine theta, and this is V naught cos theta. Okay, I took the components, and which velocity should be equal? The velocities along the perpendicular should be equal. So V perpendicular must be equals to V cos theta. V naught cos, not cos theta, V naught sine theta. V perpendicular should be equals to V naught sine theta. That comes from the constraint. So we find a relationship between V naught and V perpendicular, but V parallel will not be related. To any other velocity, because it can have its own independent value. So this is something that you have to understand, that parallel velocities can have their own independent values. The same goes for V naught cos theta. V naught cos theta is not related to any velocity. Is not related to any other velocity. For the same reason that it is parallel to the plane, it can have its own independent value. But V naught sin theta and V perpendicular, ये दोनों एक दूसरे से related हैं, और ये related हैं via constraint equations. Simple. Now the same relation could have been written down for accelerations. तो instead of velocities आप accelerations के लिए भी same equation, same relationship use कर सकते थे. There was nothing wrong with that. Alright, so you can read the topic here. When wedge and length constraints are combined. Now in a lot of cases it happens that length constraints and wedge constraints are combined, and I'll take two such examples. The idea is not to solve the examples, but to understand that how it is going to work out, how the constraint is going to work out. कंस्ट्रेंट कैसे काम करेगा? न्यूटन्स लॉज वाला जो पार्ट है वो आप एफबीडी बना सकते हो, ये कर सकते हो, वो कर सकते हो, दैट इज अ डिफरेंट इशू. बट हाउ आर देयर एक्सेलरेशंस रिलेटेड? दैट इज द प्रॉब्लम. हाउ आर द एक्सेलरेशंस ऑफ A, B and C related? Okay, and just for the sake of assumption, we'll assume that B is heavier than A. that B is quite heavier as compared to A, ki B is going downwards. So the one thing that is going to happen ki A is going upwards, A is moving upwards because B is heavy, acceleration of A, fine. This pulley is at rest, this pulley is fixed to the wall. If you are not अगर आपको ये नहीं समझ में आ रहा है कि रेस्ट पे क्यों है, so this is fixed to the wall, right? And this is your ground surface. This is your ground surface. Okay, and this is the only thing that we want to understand कि A का acceleration, B का acceleration और C का acceleration कैसे related हो. ठीक है, तो ये A से ऊपर जा रहा है. अगर ये A से ऊपर जा रहा है तो ये AB से नीचे आ रहा होगा. ऑफ कोर्स ये AB से नीचे आ रहा होगा और ये AB से नीचे आ रहा होगा, लेकिन ये जो पुली है आप ध्यान से देखो, ये this pulley is not fixed. This pulley is basically attached to C and C can move. C can move. Now I do not know in what direction C can move. मुझे नहीं पता कि C किस डायरेक्शन में मूव कर सकता है. आप सिर्फ guesses ले सकते हो. Best guess is कि forwards move करेगा, but even if I take it backwards it's not a problem. But still चलो for the sake of experience, for the sake of right assumption, we say that the C moves forward. Let's say, and it's just an assumption, I just want you to understand this. This is just an assumption. It can very well be wrong. Because C जो है वो हवा में ऊपर या नीचे तो मूव कर नहीं सकता. C can only move right or left. So either we can take right or we can take left. There's one more thing that you have to understand. If C moves right, then B also moves right with the same acceleration. Why? Because of the contact constraint. So if you will draw this contact between B and C, so this is C and this here is B, right? तो contact के perpendicular इनका acceleration same होना चाहिए. तो अगर ये AC से move कर रहा है तो ये भी AC से move करेगा. That is something that you have to understand. Got it? This will also move with AC, that you have to understand. So due to the contact constraint, it will move with AC and B will also move downwards with AB. Otherwise ऐसा नहीं होगा कि B यहीं पे रह जाए और C आगे move कर जाए, because in that case C will actually B will come within C, inside चला जाएगा, इसके अंदर घुस जाएगा, तो वो possible नहीं, right? So C और B साथ में move करेगा and this is due to contact constraint और wedge constraint, जो भी आपको contact constraint और wedge constraint जो कि अभी हमने just पढ़ा था. अब इसमें length constraint कैसे काम कर रहा है, तो ये ध्यान से देखो कि the pulley is also moving forwards with AC, and now we are going to see how the length changes at different points. So if this point P comes here, the length decreases, so we are going to write minus AA, right? This pulley is fixed, it is not responsible for change in length. But if this AC, this pulley, second pulley, if this comes forward, so let's say this point is Q and it comes here, Q dash, the length decreases, so you are going to write minus AC. And if this moves downwards, AB, let's say this point is R and it comes downwards and it becomes R dash, so the length increases, so you are going to write it as plus AB. And the most important part here is कि AC will not change this length. This AC will not change this length because AC has got no component along the length. अगर आप देखो, this is your length, and this is your AC. The angle between length and AC is 90 degrees, so the component of AC along the length is basically equals to AC cos 90 cos 90 and that is equals to 0. No component of AC along the length. तो उससे क्या होगा कि आपकी लेंथ चेंज नहीं हो रही AC की वजह से. अच्छा, सेम थिंग यू कैन अप्लाई हियर. This angle is also 90 degrees, as you can see AC and this length also 90 degrees, hence this AC also doesn't change this length. तो जब भी acceleration या velocity length के perpendicular होगा तो there will be no change in length due to that particular acceleration or velocity. Anyways, moving forward, so this will be equals to 0 and we will have AB equals to AA plus AC, and this is what we call as your length constraint. And this is what we call as your wedge constraint. So as you can see, जैसा आपको दिख रहा है कि दोनों constraints simultaneously यूज हो सकते हैं एक ही प्रॉब्लम में. अच्छा, मैंने बहुत ज़्यादा डिफिकल्ट प्रॉब्लम्स अभी ली नहीं है. डिफिकल्ट प्रॉब्लम्स मैं प्रॉब्लम सेक्शन में लूँगा. I'll teach you how to solve a lot of problems, but this is just for the understanding of your concept. तो just concept पे focus करो, and if you are feeling some troubled someplace तो वापस जाओ उस पर और फिर से देखो कि किस पॉइंट पे आपको परेशानी हो रही है. Okay, all right then.